Okay, in 2.6, they ask us in number 1 to give us a counterexample to show that this statement is false. And the statement is if a squared is equal to b squared, then a equal b. All right, here's an example. You have to think too hard to come up with one. What if a were 3 and b were negative 3? Well, what's 3 squared? It's 9. What's negative 3 squared? It's 9. So 3 squared is equal to negative 3 squared, but 3 is not equal to negative 3. There's an example right there. That's all you have to do is really show that. Basically what this gets into is that just because you square two numbers and they have the same value when they're squared doesn't mean they were the same when they started. A positive number and a negative number, when you square them, they both have the same result. So if you're struggling with it, absolute A about A minus B is equal to absolute A minus absolute value B. Okay, so let's see. We could try something. Probably this also has something to do with the negative. Let's say that let's let A equal, we'll say 7, and I'll just pick some numbers like negative 3. Well, the absolute value of A minus B in this case would be the absolute value of 7 minus 3. Well, if you remember, you work inside the symbol first, inside the grouping symbol, in this case is an absolute value. Well, 7 minus 3 is the same thing as 7 plus 3, and that would be the absolute value of 10, which is 10. But what if we split them apart? What if we had the absolute value of A minus the absolute value of B? Well, that would be the absolute value of 7 minus the absolute value of negative 3. And that would just be 7 minus, well, the absolute value of negative 3 is 3. So 7 minus 3 is 4, and 10 is not equal to 4. So there's a counterexample there. Okay, you have these proofs to do, and you're not really doing the whole proof. You're just giving the reasons similarly to what you did in geometry. So you're trying to remember all the things that were given to you. Actually, I think I put them in the Chapter 1 packet. You can flip back to Chapter 1, but I also had them in the packet that we did to kind of shorten the amount of time we spent on Chapter 1. Number 5 says they want us to prove that the opposite of a product minus AB is equal to A times minus B. Basically what that's telling me is that I can put that if I got two things that are negative, two things that are multiplied and they've got a negative in front of it, I could put that negative sign with either the A or the B is kind of what this is kind of getting at. So for the proof, if you look, it says 1AB equal negative BA. Let's see. We could say that's true because of, I'm sorry, there was supposed to be a negative out here. I was looking at it going, something's wrong here. AB is equal to BA. If I just kind of look at it as I'm just doing this, grouping these things together, and they both have a negative out front, then that's just the commutative property of multiplication. So I'll just put commutative property of multiplication because when you multiply, you can switch the order of things, and that's what the commutative property says. Step 2, negative AB equal negative B times A. Okay, what's going on there is, let's see, negative AB is negative B. You're just, it's almost like I'm just associating the negative sign with the B. It was associated kind, if you wanted to look at it up here, it's almost like up here they were associating it with the A. It's almost like we have like a negative 1 times A times B, and all we did on the first step was leave the negative 1 where it was and switch the A and the B around. Well, down here, we've got negative AB. It's kind of the same thing going on. We're looking at this as negative 1 times B times A. It's just that that's regrouped. They regrouped the negative down here with the B, okay? So that would just be the associative property of multiplication. That's what we could look at that one, okay? All right, the third step says, and they actually, on number 2, they said see example 4. When they tell you see example 4, they're wanting you to go build off of that, and the reason I want to point that out is just in some of these things, they've already taken the time in the examples to prove some things. And if you haven't looked at the examples, you don't know that. So we may go through the examples in class, I'm not sure. But anyway, you could also have put example from example 4. Okay, so every time you see that pop up in something that you're assigned, they're wanting you to go back and look because probably have already done that work and they're just having you use that, okay? All right, so step 3. They have, therefore, negative AB equal A times negative B. And that's just substitution if you look at it. I don't have the answer book in front of me, but I'm pretty sure we're doing this right. If negative AB was equal to negative BA up in the first step, and then negative AB is equal to negative B times A, oh, that's not substitution. What that is, if you look, they've regrouped it again. Well, they've switched the order again. So let's look back up at the last step. Let me use my yellow so I can kind of highlight some stuff. Here they had negative B times A, and it looks like what they've done here is they've just switched the order. So that actually would be the commutative property of multiplication again. Okay, so I always look back at the step in front of the one you're working on. I was kind of not doing that for just a second, and when I did, I saw that we could just say that's commutative, because all they did, if you look at these yellow circles, they just switched the order of them. And then number 7, they want you to prove that A plus B minus B is equal to A. And so here they go with the proof, and we're supposed to give the reasons. Okay. So 1, A plus B minus B equal to A plus B plus negative B. And what the reason there is, that's the and I'm going to write the reasons in a different color just so they'll stand out a little bit more. That's the definition of subtraction. If I'm subtracting a number like minus B, that's the same thing as adding a negative. That's the definition of subtraction. I can't fit all the word on one line, so I'll just kind of scribble it there. If you can't read it, it's the definition of subtraction. Okay, so when we get to step number 2, they have A plus B minus B. Notice that on the left-hand side, they keep the same expression every time. So where they're messing with stuff's on the right-hand side, if you haven't noticed that. I think that's what threw me in the one above it. All right, A plus, now they're going to put B plus negative B. What have they done? Haven't they just regrouped it? Look up here. You had A plus B grouped together here, and then you have the plus negative B, but all they've done is changed it, and now they've grouped those things together. So that's the associative property of addition. I'll write it in blue. So 2, the reason is the associative property of addition. That's why the reason that we had to rewrite that minus B as plus and negative B is if you remember, subtraction is not associative. You can't just change the order around, but if I change it to adding a negative, I can then work with reordering it. We don't have a law for associative property of subtraction, but we do have one for addition. All right, if you're looking at number 3, it's A plus B minus B. Again, they've left the left-hand side the same in case this is kind of throwing you a little bit, is equal to A plus 0. Well, why is that? Well, B plus negative B is 0. That's opposites. And I'm going to bet, if you look at example 6, they actually prove that. Well, that's not really where they did it. Let's look and see. We can just use that property, even though we don't see it proved here. We actually had it listed before, and that's because the property of opposites for addition. Let me come over here. So all they've done is say B plus negative B is 0. So that's the opposites property of addition. We get the identity. When we add opposites, we get the identity, and that was one of those things that we had on our sheet from chapter 1. Okay, number 4. Oops, I meant to write that in black. Number 4, and our last step here. Therefore, okay, so we're going to rewrite, if you notice what they're doing, they're going to rewrite the thing they asked you to prove above. A plus B minus B is equal to A. Well, why is that true? Well, if you look back one step above, what is A plus 0? A plus 0 is A. And that's the identity property of addition. Sometimes people will say that's the additive identity. You can say it a couple of different ways. Different books kind of word it differently. And so that's what's going on there. And that's all that we had assigned on that section was 1, 3, 5, and 7.